All right, today you're going to be taking notes, and we are going to fill in 10 and 11 on your table of contents. Number 10 is going to be the Pythagorean theorem. And distance formula. The Pythagorean theorem and distance formula, it's page 10, and page 11 is practice. And while you're taking notes, ladies and gentlemen, since you're doing them on a video, please feel free to pause the video if you need to catch up to what we're writing, or if you need some extra time to think, you can pause the video. Some students also find it helpful to put on closed captioning during the video so that they can read while they're listening to it, so that it provides a little bit more information. If you need to borrow headphones, we have some at the back of the room, or you can use your own. Here we go, page 10. Page 10. Pythagorean theorem and distance formula. Pythagorean theorem and distance formula. So we're going to be using the Pythagorean theorem, and we're going to be using this thing we're going to learn called the distance formula to find the length of a side. So this distance formula and this version of Pythagorean theorem are used to find the distance between two ordered pairs on and off a graph. So you're going to have two ordered pairs, x, y, combos, and you're going to be finding the distance between those 2 points. So the Pythagorean theorem is what we use when it's on a graph, and we're going to use the distance formula when it's off the graph. So we're going to be finding the distance between 2 points, 2 ordered pairs, on and off a graph. Now it's not going to be as simple as here's one ordered pair 0, 0, and here's one ordered pair 2, 0, right? I can find the distance between those because they fall on grid lines. What I'm going to be doing is finding the distance between 2 points that form a diagonal. Because when it's a diagonal, I can't count the distance, right? Like this piece right here is not 1, and this is not 2, and this tiny piece is not 3. So I cannot count the distance. I cannot count the number of spaces it takes up because it's a diagonal. It's going through multiple places. It's not going through an entire spot. Right? If it was a vertical line, I can count that distance. If it's a horizontal line, I can count that distance. Right? I can count 1, 2, 3, 4, 5, 6. But I cannot count a diagonal line. We're going to use this ability. If I can count vertical and horizontal, we can then find the diagonal. So here's an example. Let's draw a really easy graph. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And let's put some ordered pairs. Let's do -2, -4. And let's do 2, 3. If you look, that's a diagonal line between -2, -4, and +2, +3. That's a diagonal line. And I can't count because it's a diagonal. I can only count vertical and horizontal lines. So with that being said, I can make vertical and horizontal lines to count and then use those vertical and horizontal lines to help us create a right triangle. So sometimes step number 1 we can skip. Step 1 is to plot the ordered pairs, and lots of times in your homework and in your notes it's going to be done for you. So we're going to plot our ordered pairs and we're going to connect them. So that's already done for us. We already have that part done. Step 2 is we are going to carefully draw a right triangle. We're going to carefully draw a right triangle. We're going to use our diagonal, our distance that we're trying to find, as our hypotenuse. So I am going to carefully draw a right triangle. And I say carefully because I'm going to show you what some people accidentally do. So here's my diagonal. Let's make it a little harder to work with. Some people do a really good job of drawing one of them, but then this somehow gets off. It must be a horizontal and a vertical line. You must have that 90-degree angle in that corner. And I understand that when we draw our own graphs, we don't have those extra grid lines, so it's a little more difficult. Your examples and your homework will already have that graph provided for you. So we carefully draw the right triangle. Step number 3 is we are going to count the leg lengths. So I have 1, 2, 3, 4. That length is 4. And this is 1, 2, 3, 4, 5, 6, 7. So my leg lengths are 4 and 7. And I know that this is a right angle because I drew a vertical line and a horizontal line, and a vertical and a horizontal line are opposites, right? They're inverses, and they meet at a 90-degree angle. So now that I have my right triangle drawn, I've counted my leg lengths, I'm going to use the Pythagorean theorem to solve for the hypotenuse. And the hypotenuse is that diagonal line, the distance that we're trying to find. So a squared plus b squared equals c squared. My legs are a and b, so I have 4 squared plus 7 squared equals c squared. 16 plus 49 equals c squared. 16 plus 49 is 65 equals c squared. And the square root, so that's a little bit bigger than 64, so it's going to be a little close to 8. So the square root of 65, and I convert it using my conversion button, 6.08, or no, 8.06, C is 8.06. So that's the Pythagorean theorem. So if you're given an ordered pair, 2 ordered pairs, you're given the graph, you're given that information, you can use the Pythagorean theorem to find the distance between those 2 points. So that's Pythagorean theorem. This is the part that we already know. Now we're going to talk about distance formula. So distance formula is the new part. The distance formula. This is the new part. And this is what we use when we do not have a graph. So this is when there's no picture. They just give us 2 ordered pairs. And if we kind of talk through how we used the Pythagorean theorem, we're solving for the hypotenuse every single time, right? Because if we were just trying to find the distance between 2 vertical lines, we'd just count it. This is the distance between 2 points that are diagonal, right? So we cannot count it. So we're always going to be solving for the hypotenuse. It's always going to be the hypotenuse. So what we did was we found one leg, which is a horizontal distance, and we found another leg, which is the vertical distance. So we're going to do the horizontal and the vertical. And it's the horizontal change. If you look, our x values are the first ones. And the distance between -2 and +2 is 4. And the distance on my horizontal change, my y change, the distance from -4 to +3 is 7. So the distance formula, if we were going to just say it in words, if I was just going to, say not an algebraic expression, I would say that it's the horizontal difference, right? The horizontal difference from this point to this point, the difference between them, horizontal difference squared, plus the vertical difference squared, because the Pythagorean theorem is a squared plus b squared. And I add them together, I square them, I add them together, and then my last part is the square root. So it's the horizontal difference squared plus the vertical difference squared, and then you take the square root of that. And the formula, the algebraic way of writing this, the algebraic formula looks like this. x2, meaning the x from the second ordered pair, minus, because that's the difference, x1, the x from the first ordered pair, squared, because that's your horizontal difference, squared, plus your vertical difference, the y from the second ordered pair minus the y from the first ordered pair, squared, and then we take the square root of that. So let's practice. Let's practice using this formula. Let's talk horizontal and vertical. Let's talk x, y. If you're given two ordered pairs, 3, 5, or no, that's 5, 3, and -2, -3. I don't have to plot them. I mean, you can draw a graph, you can plot them, you can find your vertical change, your horizontal change, make that right triangle, use the Pythagorean theorem. That's fine. Or you can use this formula. You can find the horizontal difference and square it, the vertical difference and square it, add them together, and then take the square root of it. So this is my first ordered pair because it comes first when it's written down. This is my second ordered pair. It's the second thing when it's written down. First, second. So I'm going to substitute into this formula. And I'm going to take the x from the second ordered pair. So first order pair, second order pair. Here's my x. And I'm going to put -2. Then I'm going to subtract the x from the first ordered pair, which is right here, 5. So x2 minus x1 squared plus, then I'm going to come over here and do my y for my second ordered pair. Second ordered pair, here's my y, -3 minus, because I'm finding the difference, my y for my first ordered pair, which is 3, squared, and then finally at the end I'll take that square root. Now remember, whenever we substitute, we use parentheses, because at this point we're going to be finding some values and they might be negative. And if you don't have your negatives inside parentheses, you will eventually get the wrong answer. There is a difference between having a negative in parentheses and squaring it and a negative not in parentheses and squaring it. So you need to utilize those parentheses. Because when I simplify this, -2 minus 5 is -7 squared. plus negative 3 minus 3 is negative 9 squared. Now, if you don't put those in parentheses, you're going to get the wrong answer. If you don't put that negative 7 in parentheses, keep it in parentheses, you're going to have negative 7 squared, and that's going to give you a negative value because that exponent only belongs to what it touches. This exponent is only belonging to what it touches. So if you put negative 7 squared, that really means negative 7 times 7. But if you do negative 7 squared, that means negative 7 times negative 7. And we know that this answer and this answer will be different. That exponent here is only touching the 7. The exponent here is touching the parentheses, which means whatever's inside the parentheses repeats. Here it's only touching the 7, meaning only the 7 repeats. So it needs to stay inside parentheses. Because when I simplify negative 7 squared in parentheses, that means negative 7 times negative 7, which is positive 49. And that's what we want. If you get a negative value underneath a radical, underneath a square root, it's impossible. We can't have negative numbers and take a square root of it. Plus the square root of 9, or not the square root of 9, negative 9 squared, it means negative 9 times negative 9, which is positive 81. So 49 plus 81 is 130. And 130 is between 11 and 12. Right? 12 times 12 is 144. 11 times 11 is 121. So I know it's going to be between 11 and 12. And if I do the square root of 130, then I'm going to convert it. 11.4. So my C, my distance, is 11.4. All right, we're going to practice. So you should have a pink piece of paper that we're going to eventually glue on page 11. I have a pink piece of paper that we're going to eventually glue on page 11. I'm not going to glue yet. I'll practice and then I'll glue. So let's do one picture and one ordered pair. So my picture, I'm going to carefully, and see how much easier this is when the graph is provided for us. I'm going to carefully draw in my right triangle. Vertical, horizontal. Do not make an accidental diagonal. This change is 2, and this is 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to do a squared plus b squared equals c squared. 2 squared plus 8 squared equals c squared. 4 plus 64 equals c squared. 68 equals c squared. And the square root of 68, again, I know that it's going to be between 64 and 81, meaning 8 and 9. Oops, 68. And I'm going to convert it. 8.25. Again, if you need to pause because we're going too fast, you totally can. Let's go down here and do this one. First ordered pair, second ordered pair. And on the side, I'm actually going to write the distance formula just so that I can refer to it. So that means x2 minus x1. Here's my x2 minus x1. So I'm going to do 8 minus negative 5 squared plus negative 3 minus negative 8. Remember your subtracting negative rules. I'm going to take the square root of that. I filled in, I substituted the values. So So that means 13 squared plus 5 squared (169 plus 25). 169 plus 25 is 194. So I need to do the square root of 194. (13.93). So my C value, my distance, is 13.93. All right, so I'm going to post a picture of this orange or pink sheet completed. I'm going to take a picture of it and I'm going to post it on our Google Classroom so you can work independently or you work it as a table as in filling in the rest of these problems until you feel confident, and then you can start your homework. I will post the worked out examples as a picture so that the notes don't go on forever. I'll post them as a picture on Google Classroom. When you're done with this, it gets glued onto page 11 and you can start your homework.